All right, so start by drawing a couple of circles over here. Okay, so draw a circle and another circle. Okay, and try to make them the same, about the same. Okay, so our goal is to have two pretty similar circles here. I'm gonna kind of cheat and just copy this one so that mine are the same. Okay, but you want two circles that are basically the exact same. Okay. And let's go ahead and put the center point. I'm just going to kind of eyeball it. Let's call that center point C. And this top circle, go ahead and put 2 points on the circle. One, I don't know, about there, and one over here. And let's call those A and B. And so now draw angle ACB. Now angle C is drawn here, or angle ACB is called a central angle. Okay. Notice that its vertex is at the center, and it has points that are on the circle. The central angle is going to cut the circle into two, what we call arcs. And arcs are just like they sound, they're arcs, okay, like arches. The minor arc is this smaller arc right here. So let's label this minor arc. So this. And the way we write minor arc, notice it's first off, it's less than 180 degrees, so it'll always be less than 180. And we name it by its endpoints, and we put a little arc symbol over it. Okay? So this we call minor arc, and it's arc AB. Okay, so this is a minor arc, and its name is arc AB. On this picture, go ahead and put A and B in about the same places as you can. We'll still have our center C. So we'll have A, B, and then go ahead and put another point. We'll put it over here someplace and call it D. Okay. Now notice we still have central angle C right here. If we go the opposite way around the circle, so if I kind of go from A through D to B, this is called a major arc. It's more than 180 degrees. And in a major arcs, we have to use 3 points. Notice when we talked about arc AB, we would still be talking about this little guy right here. That's not what I want to refer to. I want to refer to this whole thing. And so we use 3 points. We call it arc ADB. Okay, where D is some other point on the circle. Okay, now the order of the letters here doesn't matter. It's the endpoints that matter, so we could call this BDA as well. Okay, we couldn't call it DBA because that would be from D through B to A. Okay. So if you're given 2 points, or if you have 2 points on an arc, you're talking about the smaller arc, the shortest distance between the 2 points. If you have 3 points, you're talking about the longer distance between the 2 points, basically. So let's do a quick example. Just name and give the measures of the central angle, the minor arc, and the major arc. So first off, the central angle isn't the larger angle here. We don't think of that usually as the central angle. We usually think of the smaller angle here as the central angle. All right, so the name of that angle would be angle ACB. So we want to find the measure of angle ACB. Now, the thing you need to remember here is if you get an angle inside and it makes a circle, there's 360 degrees. That's what you need to remember. So 360 degrees. So if we know that this whole thing right here is 298, then to get this smaller one, we would say 360 minus 298, which is 62 degrees. So the measured angle ACB is 62 degrees. That's the central angle. Now the minor arc, well, that's the smaller arc here, right, which would be AB. So we're going to say arc AB. And specifically, I'm going to say the measure of arc AB. There's that little M is for measure. The measure of arc AB, well, believe it or not, this angle right here is the exact same as this arc. We talked about the measure. Okay. In fact, if we look back up here, we see the minor arc has the same measure as the center angle that measures less than 180. So this arc is the same as this angle as far as measure goes. And so the measure of arc AB is also 62 degrees. Now the thing you have to remember here, we're not talking about the arc length. We're not talking about how long it is. We're talking about the measure of it, which is referring to the same as the central angle. Okay. The measure of the major arc, well, that'd be going the opposite way here, all the way around. So we call this arc ADB. So put the arc over it. And that's going to be the same as this larger, I'll call it the larger central angle, the 298. So this is the same in measure as this. So we have 298 degrees. So the key thing here, again, is keeping track of the minor arc, which is smaller than 180, and the major arc, which is going to be bigger. Okay? And then remembering that the central angle and the arc have the same measure. Now, because the central angles, well, I'm going to read this box. It says the sum of all non-overlapping central angles. Okay, so in other words, like in this case, the blue and the green don't overlap. The sum of those will always be 360 degrees. Always. Okay? And so for the same reason, because the arcs and the angles are the same measure, the arcs will always add up to 360 as well, in non-overlapping arcs. Okay, so we can kind of, if you think about it like this, on this picture, we have this arc, right? We've got this arc, and then we've got, I'll put red, this arc. If we add all of those up, we'll get 360 degrees. Okay, and the same reasoning. This angle, and this angle will all add up to 360 degrees. Okay, so it says find the measure of angle ACB. Well, ACB would be this whole angle right here, right from A through C to B. Okay. Now we know this ACD is 78. We don't know this angle right here, except we do know that the angle will be the same as the arc. So if this is 30 degrees, this is 30 degrees. And so we can say the measure of angle ACB, that'll be 78 plus 30, which is 108 degrees. So any problems so far? All we've got is the new vocabulary, this idea of major arc versus minor arc. In other words, semicircle. Well, semi means half, so a semicircle is half a circle. The diameter of a circle separates the circle into two semicircles. So if we have a diameter, we know we have two semicircles, and we also have two arcs that are 180 degrees. Okay, so if we cut a circle in half, we get 180 degrees in each arc. Okay? Now this is useful because notice it says AB is the diameter of circle C. It says find the measure of angle DCB, arc DB, arc DBA, and angle ACB. So since AB is a diameter, that tells us that arc AB is a semicircle. All right, so arc AB, I'm just going to label it. It's a semicircle. Okay. Let's find the measure of angle DCB. Well, angle DCB is kind of given to us, right? It's 48 degrees. Okay. So the measure of arc DB will be the same as the measure of that central angle. So the measure of arc DB is also 48 degrees. Now let's just define the measure of arc DBA. So this is a major arc. Okay. And notice that it's made up of arc DB and this semicircle. So what's the measure of arc BA? What's the measure of this arc? Okay, so I'm going to put right here 180 degrees. That's the implication. The fact that it's a semicircle means it's 180 degrees. And so we can say that the measure of arc DBA would be that 48 plus the semicircle, so plus 180. And so we add those together and we get 228 degrees. And finally, it asks for the measure of angle ACB. Well, let's see. ACB, what's the measure of that angle? Okay, it's a straight angle, and so it's 180 degrees. Now notice that segment ACB, angle ACB is the central angle for arc AB. Right? And notice they're the same, 180 degrees, 180 degrees. Finally, it says find x, and then use that to find the measures of ACB, BCD, and DCE. So all of the arcs on this picture, we've got 1, 2, 3, 4. All 4 arcs are labeled, but they're labeled in terms of x. Right? And what do we know they have to add up to? 180. Oh, it's a circle, so 360. All right, so if we add all these up, just going around the circle, x plus 2x plus 4x plus 3x plus 10, we know that has to equal 360 degrees. And so we have an equation. We have an x, so we can solve it. So combining like terms, 3x plus 3x is 6x plus 4x, so we have 10x plus 10 equals 360. Subtract 10 from both sides. And so we get 10x equals 350. And divide by 10 on both sides, and we get x equals 35. Well, we found x, right? But now we want to use that to find ACB, BCD, and DCE. Okay, so the measure of angle ACB, what's here? ACB. ACB. Well, that arc is going to be the same as this angle, and so ACB is x. All right. And we just found x to be 35. So the measure of angle ACB must be 35 degrees. Measure of angle BCD. Let's see here. BCD, that's this angle. It's the same as this arc, so it's equal to 2x. Well, 2 times 35 is, so 2 times 35 is 70 degrees. And then finally, DCE. Let's see. DCE, this angle will be the same as this arc, and so it's equal to 4x. And so 4 times 35 would be the same as 2 times 35, so 140. So as you look at the assignment, make sure you read the directions on each problem, because you want to make sure you're answering the question. Number 1, it says name and give the measures. I'm going to underline name, give the measures. That's 2 different questions, right? Naming is using the appropriate notation, right? That's appropriate points. And then giving the measure means actually giving the angle or arc measure in degrees. Okay. All right. Questions, or anybody need to go back to the previous slide or anything? All right, the way you started on this practice, there's only 8 problems. I anticipate most of you guys finishing with time to spare. Okay, so use your time wisely, get it done, and then everything else for you to do today. So you can hang out once you finish. Okay.